I want to talk about word problems in Algebra 1. Now, we teachers always have a problem, and that is if we make the word problems too hard so that they're realistic, we put in all these realistic real world things, then students can't solve them. The math that they need to practice with gets lost in all the massive complexities. On the other hand, if we make the word problems easy enough that they can be solved with the skills that you're learning, then they're dumb and they sound ridiculous. So I'm going to go over some word problems and just take my word for it. They're going to be dumb, but that's just the way it is. We're practicing the skill of picking out the crucial information and writing the equations and solving a problem. So I have set it up so that I have a few word problems, 2 of them in fact, written down. So let's look at one. These are both, by the way, what are called uniform motion or motion problems. Motion with steady motion, no acceleration, no speeding up, no slowing down, just something going at a steady speed. So let's say we've got a student leaving for college and they drive away and they're going 65 miles per hour. And 1 hour later, her dad says, "Oh my goodness, she left her calculator at home." And being such a dweeb that he can't think of what to do, just by texting and saying, "Hey, you left your calculator at home," he gets in his car and drives after her going 75 miles an hour. And the question is, how long does it take for him to catch up with her? Well, you might think we don't have enough. Here is a strategy for solving this kind of a problem. We're going to use a formula that you've probably noted at one time, that distance equals rate times time, or D equals RT. I don't know why that's so familiar to everybody, but that's one that's just blazed into my head. And I am going to make a table with a row for the student's car and a row for the dad's car. And across the top, I'm going to put rate for one column and time for the next column and distance for the third column. I switched the order just because I know I'm going to be multiplying going across, and so why mess with my mind even farther than I have to. Okay, so now I'm going to plug in the information from the problem. We've got the 2 rates, so we put in 65 for the student, 75 for le dad, and the time we don't see. So we'll just call one of them t, and then the other one is either t plus 1 or t minus 1. And I always have to really think that out. In fact, it's like I just have to sort of think something like this. Okay, if the dad leaves 1 hour later, then at that moment, the dad's time is 0, but the student's been going for an hour, so the student's time has got to work out to 1. So, okay, the dad's time will be t, and the student's time is the one that'll be t plus 1, because that's the one that when we plug in a 0, it's got to be 1 for the student and 0 for the dad. Okay, now using rate times time equals distance, I can write this first row as 60, the distance is 65 times t plus 1, and the second row, the dad's distance is just 75t. Now, we've got 2 formulas for the distance. Now we ask ourselves, okay, is this a case where we're adding up distances and getting a total distance, or is it that the distances are the same, or is it something else? And by the way, we should always draw a picture of the situation. It's kind of hard to draw a picture when one person's chasing another You know, I might do something like, oh, here goes the student from, there's a beautiful car, and they get to a certain, you know, place, 1 hour of driving. And then the dad gets into their car, bigger monster car, vroom, vroom. But at this point, the student is an hour ahead. So the dad's going along, they haven't started yet. And then after some time, the dad's going faster, so dad's going to eventually catch up. And I didn't leave myself enough space, but we can just sort of imagine they're going to reach a point where the distances is the same. Distances are, but distance is. Okay, if the distances are the same, then our equation must be that 65t plus 1 equals 75t. That's easy enough. And now we solve the equation. 65t plus 65 has to equal 75t. And I'm going to assume that this is fairly easy for you to solve, that you subtract 65t from both sides so that we have 65 equals 10t, and therefore t is 6.5. Now, we should plug in that 6.5 and check that it's going to work, but let's skip to the last part, which is answer the question. The question is, how long does it take him to catch up with her? Okay, well, we do have t, so that's good, but we got to answer the question in terms of the question. It takes 6.5 hours. Yikes, that's a long time. Now, in real life, when you've solved a problem, you would ask yourself, is that reasonable? Does that pass the reasonableness sniff test? And you'd say 6.5 hours, who's gonna drive at a steady 75 miles an hour without getting a ticket and without their foot falling off? Maybe they got cruise control, but without having to go to the bathroom and without wanting to stop for food, nobody's gonna drive for 6.5 hours. But this is a fake problem, it's a dumb problem, it's just to practice the skill. Okay, I set up one more, so bear with me again. I looked up the distance around Crater Lake. Crater Lake has a 33-mile rim road that goes nicely around the crater. I didn't mean to zoom out there. So one car sets off going this way around the rim, and the other car sets off going the other way around the rim, but slower. So they're going to meet at some point that's not exactly on the other side of the rim, but close. So car 1, car 2, rate, time, distance. And once again, I gave us both rates, 25 and 30. The time I didn't give, but they're both driving for the same amount of time this time. So we're just going to call it both t. And therefore, the one car's distance is 25t, and the other car's distance is 30t. But in this case, our equation is not going to come from the distances being the same, because they're not. Remember, this slower car is going to go less distance, and this faster car will go more distance. So what really is true is that the distances have to add up to the 33 miles around the rim. So we write 25t, which is the first distance, even though it's got a t in it, it's a distance, plus 30t has to add up to 33. And now we solve it. 30 plus 25 is 55t equals 33. T equals 33 over 55, which you can divide an 11 out from both of those, and it's 3/5. I didn't even plan it that way. It's just one of those lucky things. And so it takes 3/5 of an hour. And that's the answer. No, it's not, because here the question was not how long does it take, it was how many miles has each one gone when they meet up. So we've got to plug that 3/5 into the distance formula. Car 1, we say 25 times 3/5, and that gives us 15. And for car 2, it's 30 times 3/5, and that gives us 18. So we would say this, the first car, slow car, goes 15 miles, and the fast car goes 18 miles. Anyway, there was a couple of word problems and a strategy for solving them. Good luck to you, and thanks for listening.